Hello and welcome to the course on manufacturing technology theory and practice, how a rack can be fabricated. So, you know what is a rack and pinion mechanism, we have shown it to you. So, here these teeth have to be cut. Okay. So, the difference between the cutting the teeth on the rack and the cutting on the spar gear is that we do not have to find out the angles and all, or the bevel gear for example, you have seen. Here only thing that you have to find out is what will be the pitch given a module. So, pitch means the distance between the two teeth, let us say, or two the minimum distance. Now, for the calculation of the pitch, the formula is well known. This will be one module into the pi, and suppose the module you have taken as 1.5 millimeter. So, according to that module, we will be selecting the milling cutter, and we have selected the milling cutter as 1.5 module. Now, therefore, the pitch will be 1.5 into pi, which is 4.7 millimeter. So, that means that one tooth has been fabricated, and to go to the next position for cutting the next tooth, we have to move to 4.7 millimeter. All right. So, that movement is done with the help of different knobs we have, different handles we have. Say this is the handle which is used for the cross feed. Okay. This is the handle which is used for lifting up the machine up and down, and here we can see a handle. So, that handle is used for the longitudinal feed. So, in all three axes x here if we say, so the y here if we consider, and the z is along the vertical axis. So, this is for the vertically moving the table up and down. This is the longitudinal feed given by that handle, and this is the handle which will actually give you the cross feed. Okay. Cross feed to cover the entire depth, okay, for the or the entire width of the teeth. So, now again Mr. Srinivasulu will demonstrate you that how the teeth on the rack can be fabricated. For that we have a blank here. Okay. For that purpose, in fact, there could be two blanks simultaneously clamped, and with the cross feed both the gears can be cut on the two different blanks. So, that is just to increase the productivity. All right. So, at a time there will be two complete racks will be produced, and the particular gear, a particular milling cutter has been selected with a certain module which we have selected as 1.5. So, this is the milling cutter with the 1.5 module selected for this particular rack. So, please Mr. Srinivasulu will demonstrate how the rack can be fabricated, can be cut.
And we can see digitally.
Yeah, this will be digitally displayed. That is the pitch.
Will be digitally displayed, and no need to see here with the least count given according to the width.
Meaning that whatever when the handles will be rotated x, y, z as I shown it to you, you can see the value there in the display, and then you can be ensured that the value is set, required value is set. Yeah, you just demonstrate it. I will explain because you do not have mic. Okay, now this is fixed in at a certain position, let us say 0 position, and that can be set and that can be seen in the display as we have told you. The display will actually show you what will be the longitudinal feed given, what is the feed given axially, and how much movement has been done upwards and downwards. So, all these three axes x, y, z are displayed in there that you can see. Yeah, please. So, we can set the values now. Let us say this is the x axis is 0, all right. Yeah. So, now it is the depth, that is the z axis, and then Yeah, so this is so that it can touch. This is the cross feed given. You can see these values in the display as well, that how much it has been given. Okay. Now, the machine is on, and as you can see the milling cutter rotates, and it will be given a cross feed, so that the entire length of the tooth can be machined. So, making sure that the workpiece is tightened in the fixture. So, the entire length is being fabricated. Okay, now we will be giving the pitch, because we have to get the next get ready for the next tooth. So, for that we will be giving the pitch, and you can see the x axis is being changed. So, it has to be 4.7, right, 4.7 pi into module. So, pi into 1.5, which will be 4.7. Yeah, 4.7 millimeter has been moved for the next tooth, and the next tooth can be similarly cut as the first one. Yeah, so the two teeth have been cut on that rack, and though as I am repeating once more that here the calculation is very simple. You have to simply calculate the pitch, and the pitch can be calculated as pi into module, and the module we have selected as 1.5. So, that makes the pitch as 4.7 millimeter, and each time after you cut one tooth, you have to move to x axis, along the x axis, the according to the value that you have got, that is 4.7 millimeter, and the next tooth is ready for cut. Now, we are going to demonstrate the operation on a vertical milling machine, and as I told you already, the difference between vertical and the horizontal milling machine is that the axis is vertical in case of vertical milling cutter, vertical milling machine, axis of the spindle. So, here is the milling cutter, and this kind of a milling cutter I have demonstrated earlier, that these are the inserts, okay, and these inserts are very expensive. So, therefore, the material for the insert is one is the cutting tool material, and this material which is used to make the mandrel or the holder of these inserts, this material is different from the material used in the inserts. So, these inserts are actually the cutting tools. Now, this is the vertical this is the tool for the vertical milling machine, and as you can see that the difference between the tools in the milling cutters in the vertical milling machine and the horizontal milling machine is also there. That means, in case of horizontal milling machine, you have seen that there is a central hole in the milling cutter, and with the help of the key and the keyhole, the milling cutter is inserted or fixed in the arbor. So, here it is a spindle, and there is a chuck for that. So, this is inserted here and fixed in the spindle of the milling cutter. As you can see that this is the extension of that spindle on which the milling cutter is actually mounted. So, this will be the equivalent to the gearbox in the turning lathe, and this will provide the rotational movement to the milling cutter as well as the axial feed or the feed in the z direction of the milling cutter. So, here is the handle which can be used for making the z axis movement of this, that is for giving the depth of cut. Here is the blank. We are going to show you the fabrication of a flat surface, making how the flat surface can be made using the milling cutter and on a vertical milling machine. This is the vise on which the job is fixed, and the entire vise is fixed on the milling cutter machine with the T slots that the table has. All right. Now, Mr. Srinivaslu is going to show you that how this flat can be machined, flat surface can be machined. Well, now the machine is going to be operated, and the spindle is rotating along with the milling cutter. For this is for giving the depth of cut. Right now, the milling cutter is going to just touch the workpiece, from where we are giving the depth of cut. So, the x, y and z axis, they are being displayed like in the previous case, and you can see in the display that the x, y, z axis, x, y, z movement, that is movement along the x, y, z axis, they are actually displayed. So, the depth of cut is set, and then the feed is given. This is automatic feed is given to the tool, to the workpiece, and the entire flat surface is generated. So, once again the rotation of the milling cutter, you can see that milling cutter is on the spindle, and the workpiece is mounted on the table of the milling cutter with the help of the vise. On the vise, the longitudinal feed is given to the workpiece, and the workpiece is being machined. The material is being removed from the workpiece surface, and the flat surface is being generated. So, here by the feed, what we mean is the feed per tooth in the case of the milling operation. So, that you must remember from the lecture classes or the lecture slides. And let me remind you that the feed per tooth, that is the F, this is given by the Vf, that is the feed velocity of the table, divided by the number of rotation of the milling cutter n, and the Z, number of teeth in the milling cutter, Vf divided by n into Z. This defines the feed per tooth F. Whereas, if you remember in case of turning, the feed is simply given as the linear movement of the tool along the axis, parallel to the axis of the workpiece, in one revolution of the spindle or the workpiece. So, linear movement of the tool in one revolution of the workpiece, it was for case of, in case of turning. In case of milling, it is a feed per tooth, because milling cutter may have 6, 12, 18 different number of teeth. So, therefore, feed has to be defined as the feed per tooth. Okay, now you can see from the machining zone that the flat surface is almost generated, from the display you can see that how the x axis value is changing, because it is moving, the table is moving along the x axis. It is the longitudinal feed given to the workpiece, and the entire flat surface is generated. Next we are going to demonstrate you the drilling and fitting, followed by the shaping operations and how the surface can be fabricated in case of drilling, in case of shaping, and how the fitting works can be done. So, before that we would like to show you the tools. Some of them we have shown it to you earlier during the discussion on the bevel gear cutting and the spar gear cutting. So, today we are going to show you some more tools which are used for drilling and fitting operations. So, for example, we have already told you the digital micrometer, inside micrometer, outside micrometer, okay, the bevel protractor. So, these are the tools which are used in case of measuring the diameter of a shaft or the diameter of a hole, for example, with this. Okay. The diameter of the shaft again with the help of the outside micrometer. This is the digital micrometer, where you do not have to read the scale, you can read it, can be displayed here. So, this is the bevel protractor which is used for measuring the angles. Similarly, we have also shown it to you the digital vernier caliper, where the reading will be displayed on this display board, and here we have the vernier with the dial gauge. So, instead of reading the main scale and the vernier scale as in case of the vernier caliper, so you can get that value of the diameter of the shaft. Let us say if you are measuring the diameter here or here or here, this can be displayed in the dial gauge or in this display board. Now, apart from the diameter of a shaft, you can also measure the internal diameter with the help of these jaws. These jaws are used for measuring the diameter of a shaft, whereas these jaws are used for measuring the diameter of a hole. This is the stainless steel scale that also we have shown here, shown yesterday in the earlier classes. So, this is the, these are all the gauges. So, you can see that here we have the thread gauge, all right. So, here you can see the jaws, and these jaws are used to see that whether which one is fitting with the one that you are measuring, and here it will be written the value. So, you can know the what will be the pitch of the thread. So, these are for the fine pitch, these are for the bigger pitch. Similarly, you can find out what is the radius. So, here you can see the different radii are there, and all these values are written here, and this is the outer diameter, or the you can find out the radius by these gauges, what is the radius. Here you can see that these are the wire gauges. So, wire is passed through this, and here the value of each of them will be written on this disc. Accordingly, you can determine what is the diameter of the wire which is going through, passing through one of these slots. Here also you can find out, you can measure the radius the same way that we have done it here. For this, this is for the bigger radii, these are for the smaller radii, and here we have the depth gauge, and the depth gauge is, so if you have to find out what is the distance between this surface and this surface. So, this is how you are measuring, and you can read the scale, there is a scale here. So, this scale will show you what is the size, okay, what is the dimension. Similarly, this is the depth micrometer, here it is more accurate. So, again if you have to find out the distance between this surface and this surface, you are putting it in one of the surfaces, okay, and putting this stylus up to the surface that you are measuring. So, when it is touching exactly, all right, you can see that this is touching, and after that it will not go, because here the mechanism is such that it will afterwards slip. So, then you can read from the main scale here and from the vernier scale here what is the distance, and that distance is the distance between these two surfaces. So, this is the depth micrometer that you can see that it has a vernier scale, and it has a main scale, and it has a circular scale, circular scale and the main scale. From here you can find out what will be the actual distance between the two surfaces, or what is the depth of a hole. For example, if there is a blind hole, so that blind hole, how much up till what is the depth of that blind hole, that also can be found out from this depth micrometer. This is a tri-square, and this is taken for, this is used for getting the 90° exact 90° angle. So, if you have a slab, for example, let us say this has to be checked whether it is at 90° or not. So, you put that here, all right, and look at the light. If the light is passing, so that means this is not exactly matching with this surface, and this surface has to be further processed, and so on. So, this is for quick checking that these two surfaces are exactly at 90° with the help of this tri-square. These tri-squares you must have used also for making drawings, okay, when you have to make the perpendicular lines, okay, or parallel lines, then the similar tri-squares are also used. This is a combination set, and this combination set is used for measuring the angle. Okay. So, these are the typical angle given. So, again this is a kind of a gauge, all right, and here it is 90° you can say, and this angle at a certain angle is given. So, accordingly if it is matching with that particular surface, so you can be ensured that that has the angle between the relative angle between the two surfaces will be according to this angle which is given here. So, this is a complete set, that is why it is called the combination set. This we have already told you as the spirit level. This is the drill sleeve, this is the countersink drill, this is the center drill bit, this is the straight shank drill bit, and this is the taper shank drill bit. So, about this drill sleeve and the drill bits, I told you few things last time, that countersink drill is to make the countersinking process, okay, and you know that the countersinking is used for special purpose bolts. This is the center drill bit. Center drill is made to hold the shaft at the centers. That also last time when we were making the lathe operation, or when we are fabricating the part on the lathe machine, we have shown you how this center drill bit is used for making the center holes. This is the straight shank drill bit, because the shank here, as you can see, is the straight. So, therefore, it is called the straight shank drill bit, and this shank is connected to the tool holder, drill chuck or drill holder. So, that we have shown it already. This is the taper shank drill bit, where we have the taper, which is the Morse taper, and it goes into the drill holder or the drill chuck, which also has a Morse taper inside. So, those two surfaces, that the inside surface of the drill chuck and the outer Morse taper of the drill bit, they will match, and the torque will be transmitted from the spindle, drill spindle to the drill through the friction between the two surfaces. okay, the more taper surfaces. This is the adjustable spanner, the distance between the jaws which will actually hold the nut, okay, or the screw head, that can be adjusted by this by this screw. So, this you must have seen that this is being used by the people who come for repairing the taps, okay, and the household, for the household uses. Okay. Now, this, as I said, is the drift, or it is also the instrument which is used for removing the drill from the drill chuck. These are the Allen keys, this I have already told you, this is a dial gauge, this is the angle protractor. So, this is to measure the angles, as well as the linear scale can be used. The linear scale that you have here, that also can be used for measuring the length of a line or a surface, and this protractor, this can be used for measuring the angle. This is for marking the blocks. Blocks are normally either painted or made in some marking on the surface by chalk, and then on that this edge will be used, can be used for making the line or making the center for making a hole, and so on. This is a keyless drill chuck. This has already been told to you that this is a collet chuck and is equivalent to a mechanical pencil, if you remember, I told you earlier. This is the vernier height gauge, also has been told to you for measuring again the height, that is the distance between two surfaces. Well, after that we will demonstrate you some tools after the drilling. All right. So, you have seen the drill and how a drill looks like. So, after the drilling operation, it is normally the reamer which is used, and the operation that is made is called the reaming operation. All right. Reaming operation is made not exactly to remove the material, because most of the material will be removed by the drilling operation, but the reamers are used, or the reaming operation is used to make the hole better, in the sense that the accuracy of the hole, to enhance the accuracy of the hole. So, that is the basic purpose of the reaming, when the tolerance is very close. So, the reaming operation has to be used, because after the drilling what happens normally is the surface finish is not very good, because drill always have a vibration, drilling machine will always have a vibration. So, because of that the drill hole diameter will be slightly more than the diameter of the drill, that must have been told to you. So, after that, to increase the accuracy, okay, of the hole, the reaming is used, so that the close tolerance can be obtained. And this is the hand reamer, where you are using a holder. Okay. So, this is kind of a range. So, it can be fixed in here, and then it can be given the torque. So, this is the hand reamer, and we will show you the operation, the hand reamer operation in the machine, whereas this is the machine reamer. So, in of course, the difference you understand that in machine reamer it has to be a more taper shank, like in case of drilling that we have shown. And this, if you remember, I told you in case of drill, this is called the tang, T-A-N-G. This is used to remove the reamer, machine reamer from the drill chuck by using the wedge shaped tool or wedge shaped part that I have shown it to you. Now, here this, so that you could know that this is called the chisel. So, this you must have seen with the carpenters, all right. This is the scriber that I also told you, to scribe, to make a scratch line on the metallic surface and mark it. This is the C clamp. C name came because of this shape. This is in the shape of the C. So, within these two jaws, this is fixed, this is movable. You can actually fix whatever is being whatever is required. So, it can be a flat surface, it can be a cylindrical surface, whatever has to be fixed here. So, within this space between the movable jaw and the fixed jaw, it can be fixed. This is the scraper. So, this also you must have seen with the carpenters, all right, along with some kind of a chisel like this. These are also used for the fitting shop. See that these are the center punch. So, center punch is used to manually punch and mark the center where the drill has to be, hole has to be drilled. Because if you do not have a marking, in that case the drill may not actually go or say or start drilling according to the center that is desired. Then we have different kind of pliers, and those pliers you must be familiar with, because they are also used in the household purposes. These are the different kind of pliers, all right. So, they are very extensively used in the laboratories as well. Here there is a unique file that is not very popularly seen. This is the wooden file. So, this wooden file is mostly used for the wooden purposes, wooden surfaces. And here if you can see that these teeth are quite pitch is quite rough, in the sense that they are bigger, all right. So, if you see the direction of these teeth, then you can realize that as it goes in this way, then it can actually remove the material, meaning that it can actually file the surface, because in that case the wood will be removed, and when it is moving in this direction, it is not removing, but it is actually smoothing the surface. So, on both directions, when you are doing that, you are removing the surface and then you are smoothing the surface, meaning that those bars which are present after you remove, because it is a wooden surface. So, therefore, the bars will be there, and those bars can be removed and the surface can be smoothened when the file will be pulled in the other direction. So, this is a very useful file. These are different kind of files here. You can see these files are very fine files, and they are all, therefore, they are called the needle files. All of them are called needle files. This is the round shape, this is the flat shape, as you can see. This also has a flat shape, and this is a square shape. So, all these files are used for filing the manually filing the holes or the flat surface or the outer surface of a groove, for example, and so on. So, this is just to smoothen the surface, that is to remove the bars and the scratches on the surface which are there. These are all the files. From here to here you can see that all these files are of different types. They are all used for the same purpose, that is to smoothen the part, that is to remove the bars particularly. You have seen the needle file. Here you can see the double cut flat smooth file. Double cut because here there are the directions of these teeth, or so to say the teeth, because teeth are here, there is a grooves. These are in two directions, one in this, another is along this direction, 90 degree to the other one. So, therefore, it is called the double cut flat smooth file. This is the knife edge file, because of the shape of the file that name is given, and you can see that this is in the shape of the knife. This is the triangular file. You can see that the shape of the file is triangular, and here also it is no, this is not double cut probably, no, this is single cut, it is not a double cut. And this is the square file, again because this section is the square cross section, you can see that. this is a round file. Now, this is mostly used for the filing the holes, internal holes. Okay. And in the square file and the triangular file, the outer surfaces which will actually fit in when the triangular shape will fit in. Similarly, the square file for the square holes also where it will fit in, or the outer surface that is required to be filed. This file is called the half round file because of the shape here, semicircular as you can see, and here these files you can see that they are of different sizes, all right, and also they are of different grades in the sense that this is one is rougher, one you can see that for let us say if we compare these two, all right, you can see if we closely look at it that this is rough, and here if you see that this is quite smooth, in the sense that when you file with this file, then the material removal will be much more than the material removal you will get from this file, because this is a smoother file. This is therefore called the smooth file. So, they are basically used for the finishing, and these files are basically used for the roughing, that is when the rough operation has to be performed. Rough removal of more material has to be required. After the roughing is done, then this file is used for smoothing the surface. It is like in case of the rough cutting, rough turning and the finish turning, rough milling and the finish milling, rough grinding, finish grinding and so on. So, similarly, the filing also manually when you do that, you can have a rough filing of a surface roughly, and the final filing of the same surface. So, that will smoothen the surface, that will increase the surface finish, okay, and the surface roughness will be reduced. Well, here some more accessories you can see. So, this is the hand hacksaw. So, it is handheld, and the way that you drive it here like this, and then the metal piece or the metal shaft or the prismatic piece can be cut, or a slot can be made, for example, depending on the thickness of this blade. This is the double ended ring spanner. So, the ring type or this kind of a nut, this can be tightened, okay, nut which will be fixed here, which will fit here or here. So, they can be actually tightened. So, there are different kind of spanners depending on the size. See, for example, this kind of a thing, this can be moved. So, this is that it moves in one direction, in another direction it does not. So, these are very helpful, and there are switch over, you can fix it, and in another direction see it is not moving. It is like in the case of the cycle. In cycle also you can that in front, I mean when you are pedaling in the right hand direction, front direction is going, and the back direction it does not move. So, the ratchet mechanism is also here, you can see that, and this is activated by this switch. So, now this ratchet mechanism is not activated. So, similarly, there are different kind of the spanners which are used. These are the double ended open spanner. This I have already shown it to you. So, there are different kinds, and here also you can see that this kind of holders are used. So, you can hold it here at this end, and then you can similarly use it like in this case, all right. So, there are special holders for this, and those holders are used to hold it, and it will be exactly the same. You give me that holder. See, this is the holder, and it has a handle, and this holder fits in here, and then if you are doing that, so this will actually give the torque to this. Then we have a machine vise. So, you can see that this can be mounted on a machine bed, and with the help of this screw, it is knurled, Okay. So, this distance can be changed, and the part which has to be clamped accordingly, the distance has to be maintained. This is a puller. So, particularly it is used very effectively used for taking out the bearing when the dismantling of a shaft with the bearing is required. All right. So, this mechanism is very effective, because otherwise what will happen, you can if you hammer the you can damage the bearing. Okay. So, those bearings can be pulled from the shaft using this is called the puller. Here if you see that this is a flat plate, and on this plate the different kind of flat surfaces can be mounted, and if you see this is actually the V block. Okay. And this block particularly, it has a magnetic set. So, in this position, okay, on this ferromagnetic material plate, this if you in this position, this cannot be moved. So, because it has become magnetic, all right. This also a ferromagnetic material, and in this position the magnet is not there. So, you can move it along with this. So, if you have to move from somewhere from one position to another position, and then you fix it. So, you make sure that there is no relative movement between this block and the flat plate. With respect to that, it does not have any kind of magnetic action. So, it only has a V block, and this V block can be used for putting the cylinder, for measuring the non-cylindricity, for example. So, in that case you can make sure that the center is aligned. Okay. The center of the cylinder for which you are making the out of roundness, that is aligned. Okay. For doing that, we use this kind of V blocks. Well, we have a drilling machine we wanted to demonstrate. This is the radial drilling machine, you must have seen in many other places also. It has the drill which is mounted here with the drill chuck. This rotation is given to the drill, as well as the feed in the x direction, that is in the vertical direction, is given to the feed. Here we have, you can see that there is a collet chuck, and this collet chuck can accommodate or fix the cylindrical shank drill that I have shown it to you earlier. Here is a vise on the table, on the machine table, and this vise you can hold the job on the vise, job will be fixed, and you know that in case of drilling, the job is fixed, and the rotation as well as the thrust is the downward movement of the tool or the drill when the drill penetrates the workpiece. All right. So, both of these movements are given to the tool. In this case, it is the drill, and the workpiece is fixed on the table, which is mounted on the vise, tool vise. So, here when the machine is on, machine is switched on, the spindle rotates. That rotation can be changed depending on the required rotation of the drill. You can find out, you can determine the RPM of the machine, how much you will be requiring, and then this we can be given the z axis movement, that is the downward movements for the tool, that is the drill, to penetrate the workpiece and remove the material, to make the blind hole or the drill hole as per the requirement in the workpiece, which is mounted, which is fixed on the machine table and the vise here. So, we can switch on the machine, and you can see that while the machine is switched on with a particular RPM, the spindle is rotating. This is the automatic feed given. That feed means this is the downward movement of the drill. All right. Now, before making that, you can fix the value. at which value it should actually move, and then make that automatic. Now, manually you can also move that in the axial radial direction as it is being shown to you right now, and this handle make it in a particular position, and after that this can be feed can be given either manually or automatically with the help of this handle. This is the handle which is used for moving the entire block along with the tool up and down. You can see that there is a column, and through the column or using the column, along the column, that whole entire head along with the drill chuck, along with the drill, it is moving up and down, can be moved up and down. This is another movement which can be given to the tool, and this is about the column. Okay. The tool is moving, that is why it is called the radial drilling machine. In normal drilling machine, this kind of movement you will not find, and this is done for using a very big job when you have to drill hole in many places, in different places in a bigger job. Let us say a very big plate. In that case, the radial drilling machines are used so that the drill can be moved in various directions as have been shown to you. These are the handles which are used for selecting different direction, different tool rotation, the rotation of the drill. As you can see that now the rotation RPM has been changed than earlier one. This is the high speed, you can see that. So, as you can see, like in the case of the turning lathe, in case of turning lathe you have seen that this is done by the changing the gears in the gear train, which is in the headstock. Here also in the headstock there are gear trains, and depending on which position the handles are in, there are different gears which are in mesh, and based on that the particular RPM can be obtained, particular RPM of the tool can be obtained. Either it is a very high speed or it is a slower speed, depending on the speed, depending on the requirement, what kind of job you are performing. So, just now we have seen the radial drilling machine, and I told you that the radial drilling machines are used for bigger parts. Let us say if you have a bigger plate, I repeat, and you have to drill many holes in various places, then you have to have a swing of that drill. So, therefore, the radial drilling machines are used. Here if you see, this is also a drilling machine, this is a smaller version, and here you can drill the hole. Now, in case of radial drilling machine, I told you that the speed can be varied using the gear train, which is there in the headstock. Here the speed, for changing the speed, there is a PIV drive. PIV drive stands for the positive infinite variable drive, and that drive we will show you the operation of this drive. You must have seen in a theory book that in this the plate that is used, these are conical, and therefore, their diameter varies from the center to the periphery infinitely. So, to say infinitely, of course, in the given diameter you can say that there are finite numbers, but somehow this drive is called the PIV, positive infinite drive, variable drive. Now, from the motor main shaft, the transmission goes in through the belt drive. You can see here there are the V belts, and this V belt drive, it drives this shaft on which the conical plates are there. Those plates can be can come closer to each other, and then the diameter will be varied. We will show it to you right now, and therefore, from here to here the transmission can be varied by using the distance from the center at which the belt is in contact with the disc, and then accordingly the speed will be coming. Actually, you can see that the motor is here. So, that input is given from here to this, and from here it will come to the spindle. So, this is the output. Input coming from the motor, which is the main drive of the machine. From here through the belt, to the conical pulleys, and from the conical pulleys the variable infinitely variable drive or the speed can be given to the output shaft, where you have the spindle and where you have the tool mounted on the spindle. So, here you can see that this is small drill, which is a cylindrical shank drill, which is mounted with the help of the chuck, and this is the collet chuck. Here if you can see that there is a hole here, all right, and through the hole you can see the tang. Well, this is the cylindrical shank drill is mounted on the spindle through a drill chuck, which is the collet chuck, and as I showed it to you earlier, the collet chuck with the Morse taper surface. The Morse taper goes in the internal Morse taper of this chuck, drill chuck, and here you can see that there is a hole. Through the hole you can see the end of the tang, which is at the end of the taper surface of this drill holder. So, I already told you that this is used to remove the tang is used to remove the drill from the drill chuck. So, you can take one wedge shaped part, and then by pushing you can actually remove that. So, this is the tang, which here you are actually pressing, so that it can be disengaged from the internal Morse taper, which is holding, not only holding this tool, but it is also transmitting the torque. That is more important, the transmission of the torque is only through the friction between the two surfaces. One surface is the conical surface of this shank, and the other surface is the internal conical surface of this tool holder or the drill chuck. So, if you want to put it, you just put it like this, and it will be held between the two taper surfaces, Morse taper surfaces. Okay. Well, now to operate this machine, you have to switch it on first. So, it is a start position, and you can see that as soon as you switch it on, the power goes to the main drive, and this shaft started rotating. In its turn, that shaft transmit the power through the belt drive to the shaft here in between intermediate shaft, and intermediate shaft has this conical pulley. Now, if you want to increase or decrease the speed, you have to rotate this. So, what we are doing here, by rotating this, the speed is decreasing, and why the speed is decreasing you can see closely. You take a close shot of this disc, you can see that as we are doing this, the belt is coming towards the periphery, all right, and in that case what is happening, the belt has come towards the periphery. That means the distance is more, diameter is more. Okay. So, from the smaller one to the bigger one, the speed is reduced, and if we are increasing that towards this side, the speed is increasing, because in that case the belt is going towards the center, and the effective diameter is becoming less. Effective diameter is less, meaning that from the bigger diameter to the less diameter, the transmission is being, the power is being transmitted. Then accordingly, this 1:1 goes to the spindle, and you can see that the drill is rotating. Okay. So, the rotation can be increased, or it can be decreased. Now, you look at the spindle. Okay. See, now the rotation is very less, because we have increased the diameter, and now we are decreasing the diameter. You can see that they are expanding, and that is the maximum speed that you can actually create. So, therefore, this is called the positive infinite variable drive, PIV drive, And this PIV drive is very important because in this case what happens is that any kind of speed that you required you can get without any steps. So, continuously, and in case of gear drive you have seen that there are stepwise. So, you have a particular number of RPM, like in case of the turning lathe you have seen that there are fixed number of RPM, and if you have to use an RPM in between, it is not possible. All right. But in this case any RPM that is required, you can get it with the help of the PIV drive, which has been demonstrated. Thank you for your attention.